students, let's continue our discussion. Our next topic is nucleophiles and electrophiles. Nucleophiles, as the name suggests, they are nucleus-loving species. That means since nucleus is positively charged, they are negatively charged species or electron-rich species. So they carry negatively charged. There are two types. One is negatively charged, another is neutral. Okay. So neutral nucleophiles, they must have lone pairs. So ammonia, RNH2 is known as primary amine, R2NH is called secondary amine, HOH, that is H2O, which is water, ROH known as alcohol, ROR dash known as ethers. You may notice all of them, they have lone pair in one of the atoms. So such species, though they don't carry any charge, but they are rich in electron because of the lone pair, hence they are nucleophiles and neutral nucleophiles. And the ones which carry negative charge, such as Cl minus, Br minus, I minus, OH minus, all these negatively charged species are known as negatively charged nucleophiles. Now, negatively charged, they are also called Lewis base. Now, what are the Lewis base? If you remember, the definition of Lewis base is the species which are capable of donating electrons are called Lewis base. So, the nucleophiles, in other words, are also Lewis base. Then comes electrophiles. Electrophiles, as the name suggests again, they are electron-loving species. Since electrons carry negative charge, so you can understand they are either deficient of electron or they carry positive charge. So here also we have two types of electrophiles. One is neutral electrophile, another is positively charged electrophile. The neutral electrophiles, they usually don't have their octet satisfied. So all the free radicals, they are neutral species. Then we have boron trifluoride, aluminium chloride, ferric chloride. These are all examples of neutral electrophiles. And the ones which carry positive charge, definitely they are electrophiles. Say NO2 plus, halogen bearing positive charge is very unusual, but they do carry. You will be seeing the situations when they carry positive charge. Then all carbocations, okay, acyl cation, all hydronium ion, ammonium ion, they are considered to be positively charged electrophiles. So these terms are very frequently used in organic chemistry, and you should get used to them. The next effect is there are certain effects which regulate the reactions. One such effect is inductive effect. When a covalent bond is formed between atoms of different electronegativity, then we all know that the electron density is more towards the more electronegative element. Then what happens? Let us take this example, CH3, CH2, CH2, Cl. So you can see here the bonds are between carbon, and here we have a element which is having more electronegativity, that is chlorine. Now because of this chlorine, we know that the carbon chlorine bond out here is not like polar, because this carbon will carry positive charge, partial positive charge, and this chlorine will carry partial negative charge. This we have learned long back when we did dipole moment. Then what is inductive effect? This pulling of electron by chlorine is not inductive effect. You see, this CH2 in turn will start pulling electron from this CH2, and this in turn will start pulling electron from this, and this way it will continue. Okay. This positively charged carbon attached to chlorine, which induces positive charge in the neighboring carbons, this effect is called inductive effect, and it is a permanent effect. Alright, and it is operative in sigma bonds. Now you may note here the first carbon to which halogen is attached, we have put 1 delta and plus. The next carbon we put delta delta plus. Then next carbon becomes delta 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 plus. Now why are we increasing the number of deltas? You see, the more the number of deltas, less is the extent of positive charge on them. As you know, delta means partial. The effect decreases. You see, this will be most positive. The next one will be little less positive. Third one will be much less positive. Fourth one will be much less positive. And slowly, after fourth carbon, usually the effect is not felt anymore. Okay. The effect decreases as the distance from the group causing the polarity, out here is chlorine, increases and usually becomes negligible after fourth atom. Okay. So that is what is inductive effect. Now there are two types of inductive effect. One is called positive inductive effect, another is called negative inductive effect. By positive inductive effect we mean the groups which are electron donating or electron pushing, they exhibit plus I effect. And remember, usually the alkyl groups exhibit plus I effect. Bulkier the group, more is the plus I effect. So among all the groups attached to carbon, hydrogen has minimum inductive effect because you know it is the smallest. Then comes methyl, then comes primary alkyl, then comes secondary alkyl, and lastly it becomes tertiary alkyl group, which is having the maximum positive inductive effect. Then what are a negative inductive effect? Negative inductive effect is the groups which has the ability to pull electron towards itself. Okay, and they usually gain, not usually, they get the partial negative charge. These groups are known to have minus I effect. And the examples you have in sequence, NO2 is having maximum minus I effect followed by cyanide, then carboxylic acid, ester, aldehyde and halogens. Okay, here we have taken the example of halogen. So these are the groups which have electron pulling effect. So we call them groups with minus I effect. The next effect comes is electromeric effect. Okay, in electromeric effect what happens? It is a temporary effect. It is operative only when we have a carbon-carbon double bond or carbon-oxygen, in sense carbon forming a multiple bond with other atoms or with carbon itself, and it is operative in presence of a incoming reagent. Okay, we call them foreign reagent. So it is a temporary effect. So what happens, as you know here, the carbon-carbon double bond, if we have all hydrogens attached to the carbon-carbon bond is non-polar. But the moment we add acid here, say H plus, which is coming from HCl, H2SO4, whatever group, the moment we add H here, the carbon-carbon bond will undergo heterolytic cleavage. The bond will break towards one of the carbons. Okay, and this carbon will develop a positive charge and this carbon will develop a negative charge. Now the carbon which developed a negative charge will attack the positively charged hydrogen, and there will be a bond formed between carbon and hydrogen. You can see here the bond has formed between carbon and hydrogen, and the other carbon which has lost its electron acquires a positive charge. So we created a bond polarity because of the hydrogen out here. If the hydrogen is not there, the carbon-carbon double bond will not remain polar. So this is an effect which is operative in multiple bonds and in presence of incoming reagents. So electromeric effect, which is also called E effect, are of also two types: positive electromeric effect and negative electromeric effect. Now what are positive electromeric effect? You see, the positive electromeric effect means this occurs when the attacking reagent is positively charged. Say for example here H plus. That is, it is an electrophile. The pi electrons are transferred to the atom in which the attacking reagent gets attached. So here what happens? This is the C double bond O, and these are the two bonds to which some group may be attached. It may be aldehyde, it may be ketone, it may be carboxylic acid, whatever. Now you can see the lone pair on carbon out here behave as the nucleophile and attack the H plus, and the pi bond breaks towards oxygen. So here the incoming reagent is positively charged. The pi bond is breaking to the atom which is getting attached to the incoming species, and ultimately you are left with a positively charged carbocation. When such situation occur, this effect is called plus E effect or positive electromeric effect. Next is negative electromeric effect or minus E effect. This occurs when the attacking reagent is negatively charged. Okay, and the pi electrons move to that atom to which the attacking reagent do not get attached. So please remember that the attacking reagent do not get attached. So here C double bond C, we have the OH minus is the foreign reagent, and you can see it carry a negative charge. So it will behave as a nucleophile. So the OH minus attacks one of the carbons here. As a result, the carbon-carbon double bond immediately breaks towards the other carbon. So here the incoming group get attached to that carbon to which the pi electron do not get transferred. Okay, and we'll end up with a negatively charged species. So such effects where the incoming reagent is negative, the species which formed during the course of reaction is also negative, and the incoming reagent do not get attached to the carbon where the pi electrons move. Such effect is called negative electromeric effect. One thing you should remember, the incoming reagent may be positive or negative. It is never the positive reagent uh, attack any species. Okay, it is always the negatively charged species starts the reaction by attacking. So I'll stop my video today. The hyperconjugation will be followed in the next video. Thank you.